In this episode, we are going to take one of the most common cloud topics and make it feel much less abstract by focusing on what really changes from one service model to another. Many beginners hear software as a service, SaaS, platform as a service, PaaS, and infrastructure as a service, IaaS, presented as if they are just three labels to memorize for an exam. But they make far more sense when you compare how much of the environment the provider operates and how much the customer still has to control. The biggest lesson is not simply which model is most convenient or most flexible. The bigger lesson is that every model creates different responsibility boundaries, and security mistakes often happen when people assume the provider is handling something that the customer still owns. Once those boundaries are clear, cloud service models stop feeling like vocabulary words and start feeling like practical ways of deciding where control lives, where risk stays, and what kind of security work the customer still has to do. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. A good starting point is to understand what the words as a service are really pointing to. They mean that a provider is delivering some layer of computing capability to the customer as an ongoing service rather than as equipment the customer must fully build, operate, and maintain alone. What changes from model to model is how high up that delivered capability goes. In one model, the provider may give the customer a complete application ready to use. In another, the provider may give the customer a managed environment for building and running applications. In another, the provider may give more basic computing resources such as virtual machines, storage, and networking, leaving much more of the operating responsibility with the customer. This is why service models are best understood as different levels of abstraction and management rather than as three unrelated cloud types. They are different points along a spectrum of provider involvement, customer control, and shared responsibility. Before comparing the models directly, it helps to anchor the discussion in the idea of responsibility boundaries. A boundary is simply the line between what the provider is expected to secure and operate, and what the customer is still expected to configure, manage, or protect. These boundaries matter because cloud services are often very convenient, and convenience can create dangerous assumptions. A team may sign into a polished service, see that everything works smoothly, and conclude that security is basically handled already. In reality, the provider may be managing infrastructure, physical facilities, and certain service-level protections while the customer is still fully responsible for user access, data handling, configuration choices, business workflows, and the consequences of granting too much privilege. The cloud does not remove responsibility. It rearranges it. Good security judgment depends on knowing exactly which layers move to the provider and which layers remain under customer control, even if they are less visible than before. A useful way to compare the models is to imagine a building where you can rent different amounts of service. At one extreme, you might rent a fully furnished office suite with electricity, maintenance, internet, cleaning, and reception already handled. In the middle, you might rent a fitted space with some core services included, but still furnish it and run your own business operations inside it. At the other end, you might rent a basic empty space with power and structural support, but build and manage almost everything else yourself. Cloud service models work in a similar way. SaaS usually gives the customer the most finished experience and the least control over underlying technical layers. PaaS provides a managed application platform, but the customer still builds and manages what runs on top of it. IaaS gives the customer fundamental computing building blocks and much greater control, which also means much greater operational responsibility. SaaS is usually the easiest model for beginners to picture because it often looks like a complete application that users simply access through a browser, client, or mobile interface. The provider operates the application, the supporting infrastructure, and much of the underlying maintenance, while the customer focuses mainly on using the software to accomplish business tasks. Common examples include collaboration tools, customer relationship systems, human resources platforms, productivity suites, and other business applications delivered as ready-to-use services. This model feels simple because the customer does not usually manage the servers, storage systems, operating systems, or platform components in the same direct way they would in more hands-on models. That convenience is a major reason organizations choose SaaS, especially when they want to adopt business capability quickly without building and maintaining the technical foundation themselves. The trade-off is that convenience does not erase security responsibility. It just shifts the customer's attention toward a different layer of the problem. In SaaS, the customer usually has much less control over the internals of the application environment, but that does not mean the customer has little security work to do. In fact, customer responsibility often remains very significant in areas such as identity management, user provisioning, access approvals, data classification, retention choices, sharing settings, business process design, and deciding which people should be able to view, export, edit, or administer sensitive information. If a company uses SaaS platform for payroll, case management, or collaboration, the provider may operate the application securely at the infrastructure level, but the customer still decides who gets accounts, which roles they receive, what content is uploaded, how data is organized, and whether internal sharing is overly broad. Many real SaaS incidents are not caused by the provider failing to run servers. They are caused by customers mismanaging permissions, leaving sensitive data exposed through weak configuration, or assuming that using a reputable service automatically means the business process itself is secure. PaaS sits in the middle of the comparison and is often the hardest for beginners to understand at first because it is less visible to ordinary end users than SaaS and less concrete than renting virtual machines directly. The main idea is that the provider offers a managed platform where customers can build, deploy, and run their own applications without managing every low-level infrastructure detail themselves. The provider usually handles much of the underlying operating environment, which may include runtime support, scaling features, patching of the platform layer, and service components that help the application run reliably. The customer, however, is still responsible for the applications and data they place onto that platform. This means PaaS gives developers and technical teams a balance between convenience and control. They can focus more on writing and operating the application logic while relying on the provider for much of the supporting platform foundation underneath. The responsibility boundary in PaaS is especially important because it is easy to assume the provider's management of the platform means the customer's application is therefore secure by default. That is not true. The provider may secure and maintain the underlying platform services, but the customer still owns the code, the application design, the data model, the access control decisions, the way secrets are handled, the way application components interact, and the logic that determines what users and services are allowed to do. If a development team builds an insecure application, exposes sensitive data through poor access design, stores secrets carelessly, or grants broad service permissions, the managed nature of the platform will not fix those design mistakes automatically. This is why PaaS is so interesting from a security perspective. It removes some infrastructure burden, but it leaves the customer deeply responsible for the trust decisions built into the application itself and the way that application uses the platform. IaaS is often the easiest model to compare against traditional computing because it gives the customer more fundamental computing resources such as virtual servers, networking components, and storage while leaving much more of the operating stack under customer control. In this model, the provider typically manages the physical facilities, the hardware layer, and the virtualization or cloud infrastructure foundation that makes the environment available. The customer then creates and manages the operating systems, software stacks, applications, data handling, and many of the network and security choices within that environment. This makes IaaS attractive when organizations want flexibility, custom architecture, or the ability to run a wide range of workloads without buying and maintaining all the physical equipment themselves. It also means the customer carries a much larger share of direct operational security work than in SaaS or PaaS because more of the stack is theirs to build and protect. In IaaS, the responsibility boundary moves downward, which means the customer owns more of the environment and therefore more of the risk that comes from configuration, maintenance, and oversight decisions. The provider may give secure facilities, resilient infrastructure, and service-level controls, but the customer still has to think about system hardening, network segmentation, patching, secure remote access, logging, workload configuration, application deployment, identity control, and how sensitive data is stored and processed. A company running a virtual server in IaaS cannot assume the provider will automatically manage the guest operating system, remove unnecessary services, or prevent the customer from exposing a weakly secured workload to the internet. The flexibility of IaaS is powerful, but flexibility and responsibility grow together. Beginners should see IaaS as a model where the customer gains control by taking on much more security ownership, rather than as a model where the provider magically turns rented infrastructure into a fully protected business environment. One of the most important comparisons across all three models is how the shared responsibility line moves. In SaaS, the provider handles more of the technical stack, while the customer concentrates more heavily on identity, business use, data, and configuration within the application. In PaaS, the provider still handles a substantial platform layer, but the customer becomes more responsible for what is built on that platform, how the application behaves, and what the application exposes. In IaaS, the customer controls much more of the technical environment and must secure many more layers directly. This means there is no simple answer to which model is safest. A more managed model can reduce certain technical burdens, but if the customer mishandles identities or shares data poorly, major problems still remain. A less managed model offers greater control, but it also offers more chances for the customer to misconfigure core parts of the environment and accidentally create large exposure. A very common beginner mistake is to think that the provider always secures the cloud, and therefore the customer mainly secures only user behavior. The reality is more precise. Providers generally secure the service layers they operate, but customers remain responsible for how they use those services and what they place into them. Another mistake is assuming that more provider management automatically means less security work overall. What actually happens is that the security work shifts. In SaaS, you may spend less time patching servers, but more time managing data visibility and user roles. In PaaS, you may spend less time administering the platform itself, but still need strong application security discipline. In IaaS, you may gain architectural freedom, but you also inherit many direct infrastructure responsibilities. Strong cloud judgment comes from understanding that convenience changes the shape of customer security work, not the need for that work. A simple example helps make these models feel more concrete. Imagine a company that wants to provide an internal project management capability. If it chooses a SaaS tool, it may subscribe to a ready-made collaboration platform and focus mainly on who gets invited, what roles people receive, what data is entered, and how sharing is controlled. If it chooses PaaS, the company may build its own custom project management application on top of a managed platform, which means it is now responsible for the application logic, role design, data handling, and code security, even though the underlying platform is provider managed. If it chooses IaaS, the company may deploy its own servers, operating systems, databases, and application stack in rented cloud infrastructure, which gives maximum flexibility, but also means the company must secure a much larger technical footprint directly. The business goal looks similar in all three cases, but the responsibility boundaries and security burdens are very different. Choosing among these models is therefore not just a technical preference. It is also a decision about which responsibilities the organization is prepared to carry well. Some businesses benefit greatly from SaaS because they want reliable business functionality and have no desire to manage supporting infrastructure. Others use PaaS because they need custom applications but prefer to offload much of the platform maintenance. Others choose IaaS because they need specialized control, unusual workloads, or architectural freedom that more managed models cannot provide. The security question is not which model sounds most advanced. The better question is whether the organization understands the responsibilities that remain on its side of the boundary and has the people, processes, and governance to carry them. A company can fail securely in any of these models if it misunderstands what it still owns. The cloud model does not rescue poor ownership. It only changes where that ownership begins and ends. By the end of this discussion, the most important lesson should be very clear. SaaS, PaaS, and IaaS are not merely three cloud labels to memorize. They are three different ways of dividing control, convenience, and security responsibility between provider and customer. SaaS gives the customer a finished application but still leaves major responsibility for identity, configuration, and data use. PaaS provides a managed platform while leaving the customer responsible for the applications and logic built on top of it. IaaS delivers core computing resources while placing much more of the operating environment under customer control. Responsibility boundaries are what make these models understandable, because the most dangerous mistake in cloud security is assuming a provider is handling something that still belongs to the customer. Once those boundaries are mapped clearly, service model comparison becomes much more practical, and cloud security decisions become far more grounded in reality.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.